So we've got the C12 CAT head that came in, sold the customer a kit. Kit came in, and we were going to jump in and start doing the head. So we pick up the head. I say, hey, Dad, let's take a thumbnail picture real quick. And took the first picture with the springs facing me. You know, weren't really looking at it too close because we were getting ready to tear it down and do our cleaning. You turn it around, and as I'm glancing at it, I see a big old crack between two of the cylinders. So we're like, crap, we already got all the parts. So what do we do now?
Well, we've got all these parts we'd like to be able to use up. We don't need those in inventory. So I called one of our suppliers that we sometimes get heads from when we run into something that's cracked real bad or busted up. And normally they're selling new aftermarket heads that are complete, but they did have some that did not have the valves or anything in them, so we're going to go ahead and order one of those and replace this. Getting just a new bare casting that is supposed to be fully machined, ready to assemble. It just needs the valves and springs put in it. But it's usually a pretty good idea when you get those in to kind of go through them, check the guides, check the seats.
Check it out and, you know, make sure it's to our standards, make sure it's right before we send it out with a customer. We've learned this lesson a ton of times, but this is why we always try to stress before you go ordering parts, make sure what you have is rebuildable, right? Because in hindsight...
We broke our own rule there of ordering the parts where we knew for sure what we needed, but we were pressed for time and we was trying to save time, and instead it bit us.
Yeah. So despite there being no indications of an issue related to the crack when the customer tore down the engine, we actually found that the head was cracked on nearly every cylinder. While they weren't causing problems yet, these engines are too expensive to risk it, so a new head is in order. Aside from the cracks, it just looked like a worn-out head with some broken valve springs. Roughly a week later, the new aftermarket cylinder head came into the shop, so we got it up on the bench and got some of the new parts out to start making our final quality checks. We sold the customer an overhaul kit from IPD, and they set us up with a nice valve train kit, which was originally meant for the head that we were going to rebuild, but we'll still be installing most of it in the new head nonetheless.
95
On
intake. We are a little better than 50. So we're good there.
One critical specification that we always check on a replacement diesel cylinder head is the valve recession, and in this case the tolerance is pretty wide and the seats do appear to be cut to the correct depth. I went ahead and brushed out the valve guides as well as cleaned off the valve seats, which seem to have some sort of cosmoline coating. The next specification we always like to check is the valve stem clearance, so I measured the valve stems on the new intake and exhaust valves and set up a dial bore gauge to check every valve guide. The specified tolerance on this head is between 2.4 and 5.1 thousandths clearance, and all of the guides were just over 4 thousandths clearance. We often find that aftermarket valve guides are set on the looser side of spec, which we assume is the manufacturer's way of buying some wiggle room and preventing warranty claims. The next quality check we like to do on new heads, and probably the most important in our opinion, is checking the valve seat runout. The acceptable tolerance seems to be debated in the industry, and it also varies based on application. The first two I checked showed under 1 thousandths runout, which we would consider to be more than acceptable for this head. However, as I went down the line, most seats had much more runout, with as much as 3.5 thousandths on a few seats, which I know I can improve. I went ahead and mounted the head up on our Surrey 4.5 valve seat machine and set up a cutter that matched the angles and widths of the existing valve seat. Since we do have a depth tolerance to remain within, our goal will be to simply clean up the valve seat to improve the runout while removing as little material as possible. Some red die chem on the seat will serve as a visual aid to our goal. At first glance, I thought it had cleaned up almost instantly, but on the far side of the seat we can see that some die chem is still present, indicating that our cutter did not touch all the way around. I went ahead and coated the seat again, and again touched off with the cutter until all of the seat cleaned up. I personally like to run the spindle as fast as possible without chatter. With the first seat recut, I decided to quickly double check the position that the valve seat was contacting the valve face, which ended up looking fine. I also double checked the depth again and found that we were still well within the depth tolerance. Finally, it was time to check whether or not we could measure any improvement in the runout. As expected, we saw significant improvement, dropping the runout on this seat from around 3.5 thousandths to just about a half thou. A quick vacuum check is also a good indicator of whether or not the valves are sealing, and in this case they are. With the confidence that we could improve the runout on the exhaust seats without increasing the depth significantly, I went ahead and recut each seat. As stated earlier, I do like to run the spindle as fast as the material will allow, although in this case I found that my tool life was suffering. While running fast produced the best seat, the edge of my cutter was simply burning right off and causing me to have to resharpen the tool between each seat. I opted to slow down the spindle RPM a bit, which remedied the situation. As a quick reminder, we are coming up on 500,000 subscribers, so if you haven't already subscribed, be sure to hit that subscribe button and help us reach that goal. Also be sure to hit the like button and drop a comment, as my dad and I try to read and respond to as many as we can. We were able to bring most of the exhaust seats to right around 1,000th runout, with the worst sitting at around 1.5 thou, which is within what we would consider to be acceptable in this application. We double-checked the valve recession on each exhaust seat after having recut the seats, with most sitting right around 55 thousandths, well within our 43 to 81 thousandth tolerance. Finally, a quick vacuum check on each of the exhaust ports gave us the confidence that the exhaust valves are going to seal well for the customer. We'll repeat the process on the intake seats with a different cutter that's set up to match the existing seat profile. I also used a technique that I've shown in the past, where I start the spindle motor and touch off the cutter on the seat as the spindle is ramping up, which seems to break any chatter that may be caused by harmonics, leaving a quality valve seat. Most of the intake seats were much closer to begin with, but even so we saw improvement on the first intake seat that I cut, so I had confidence that I could improve them all without sinking the valve recession too much, and went ahead and recut each of them. When it was all said and done, all of the intake seats came in around just shy of 1 thou runout, with the best coming in with less than a 0.5 thousandth runout. The final depth of our intake seats was just around 100 thousandths on each one, which again was well within our tolerance of 83 to 122 thou valve recession. Again, a vacuum check on each of the intake ports is our final check to give us the confidence that our work is done and the valves will seal for the customer. After a final wash in our spray cabinet to ensure that the head is completely clean before assembly, we're ready to go together with our new IPD valve train components, including all new valves, keepers, inner and outer valve springs, and rotators with corresponding plastic shields that act as valve stem seals. As always, a thin coat of assembly lubricant is used on the valve stems to ensure proper lubrication on initial startup of the engine. With our pneumatic valve spring compressor, the spring and rotator are compressed over the valve stem, allowing the keepers to be set into the keeper grooves before the compressor is released, settling the valve springs into position. It's safe to say that not every job that comes into the machine shop goes to plan, but at the end of the day, all that matters is getting the customer's vehicle back in service with the best possible parts to give them a reliable engine.